All right, so hey everyone, this is KMS meeting number 3 on January 11th, 2022. So for this meeting, we had wanted to go over sort of what the tracks of work are for KMS and sort of like what we plan on doing. Let's see. So yesterday we had talked after the issue triage meeting briefly, and some of the things we discussed there were that we wanted, well, we had talked about these 3 distinct things. We had talked about the reference KMS library implementation. We had talked about the KMS observer cap that would contain, to start with, a UID server pass to KMS, and then in some iteration of this cap we would add and the third thing was figuring out the history why users. Does anybody remember anything else?
I think this looks good. This is what we talked about.
Yeah. So that covers the 3 things. Rita, do you mind maybe going over them for Damien's sake?
Can you repeat the last part?
I said, do you mind going over the 3 things just as a summary for like Damien's? That way we have it recorded also.
Yeah, maybe just before, like, could you give me an idea of the state currently of the CAP? Like, because we kind of wanted to split it into different topics, so observability, performance, and things like that. And I know we talked a bit about performance in the first place, and a lot about observability, but not yet about recovery, I guess. You give me a heads up of where we are today.
Did you want to take that one?
Yeah, so the first meeting we talked about all the different categories, right? So recoverability, observability, and performance. And then also, like, if you looked at the initial proposal draft, we had said we'll focus on observability and recoverability first, because those are things that we could get in without any breaking changes, and also based on some of the discussions that we've already had. So we decided to go with observability first. So open a KEP for it and then see what changes that we can include in the next coming release. So the KEP deadline is, I think, Jan 28th. So we want to get a KEP in before that and then try to make changes in this release. And the conversation for this, what we thought was maybe we could do the audit ID part, right? So where we can actually string the whole audit ID from the user creating the request all the way to the KMS plugin. So in the last meeting, we decided that that's something we could do, but there were a few outstanding questions that we had for the SIG Auth community. One was audit ID is user configurable, so the user can actually overwrite it with whatever audit ID they need. So we needed to understand why that is required. And then we also wanted to see if we could get a sign off from everyone on SIG Auth. And the outcome from the call was, yes, audit ID is configurable. We need to understand more on that behavior. So that's why there's a track item right now so that we can understand why it's configurable and what we need to do. And then the second thing is every request that not all the decrypt or encrypt, decrypt request comes to the KMS plugin because the API server has caching. So basically it caches the deck and the encrypted version of the deck in memory. And because of that, there is no guarantee that every request that originates from the user will actually hit the KMS plugin. So we decided that there's no way we can provide that direct audit trail from the user request all the way to KMS plugin. So we wanted to focus on something where we can correlate requests from API server to KMS plugin. So at least that enables debugging easier than what it is today. So today, if you need to correlate, the only way you can do that is through timestamps. You have to look at a timestamp in KMS, and then you have to go back and look at timestamp in the API server. But so instead of that, we were going through a couple of options, and one thing we decided to do now was the API server will generate a unique ID for every request that it sends to the KMS plugin. This will be part of the gRPC request that's being sent to the KMS. And then the API server and KMS plugin can log using that UID, and then they can also use that for auditing to start off. And then in the track 2 that we're following up with SIG Auth to understand why audit ID is in the end user's control. So if we can change that to make it less configurable, then maybe we can also hook up that audit ID with the UID that we are generating. So that's where we are now. And the next steps is we're going to write a KEP for this part of it, and then try to get that in and then start the work on this release. And then in this call and the subsequent calls, we'll plan for the other categories that we have listed in the proposal, and then also work on KEPs for those, but it'll just span across other releases.
Yeah, thanks for the summary. I think it covers like most of the thing I was wondering, because the last meeting I went to, basically we had this discussion of how can we propagate the audit information. And I think you had two ideas behind that. First was to have one ID that will be generated specifically for KMS, like some specific field just for us, or use the audit ID. So I guess the approach you are trying to take now is to switch to audit ID with the audit ID chain, I think, that Mo shared before. Is it, am I understanding this correctly?
Yeah, so right now we're starting with just the UID, but I think once we understand the track 2 for the audit ID and why it's user configurable, then we can actually chain it to, like, once we figure out that part and then fix what is there, what we have can just be chained to what the audit ID is. So we can actually also show that to the users.
Okay. And so the goal today is to like kind of answer the question that the SIG Auth people had and the concern that they had, right?
So at least the start of this call is, so we have these 3 track items. One is the reference KMS library, and then the observability KEP, and then also figuring out the audit ID. So we had a small discussion yesterday after our triage call just to understand these things and then who will pick it up. So I think here we're just summarizing, and then we're having assignees for it. And then I think also we might briefly discuss what we want to do. And then after that, we can go ahead and discuss about recoverability, performance, and security as well.
That makes sense.
I wanted to give an update. So I did speak with Tim yesterday in regards to the audit ID thing. And what I got from him was, so there appears to have been 2 use cases that were thought of for the audit ID being under control. One of them was something related to kubectl and it following redirects and like maintaining an audit ID that it received originally from the server and then continuing to pass it through. I think that use case fell through because they just decided kubectl should never follow a redirect. It's just a bad idea. It shouldn't, because the server doesn't redirect you really in any situation other than very, I think there's technically redirects in some of the exec and proxy things, but they led to problems and other things. So that wasn't, I don't think that's the case we need to worry about. The other case is aggregated API servers, which we also are not concerned about because we have an MTLS connection to them, so we can use that as our trust anchor. But the gist I got from Tim is that we could consider ignoring a end user provided audit ID when it's untrusted. Like we could make such a change, right? So what I had thought that we can do as a next step there is reach out on, like KDev, SIG Security, and SIG Auth mailing list and be like, hey, does anyone rely on this being under your control? If so, like, why, what are you trying to do, and et cetera, right? Then with that in mind, once we get a little bit of feedback, we could try to write a KEP to describe the change we want to make, right? Like, so the end state would be only trusted actors can set this. So aggregated API servers can, or front proxies in front of API servers can set this. Totally fine. You know, they're root on the cluster. That's totally fine. You know, you could even imagine a authenticated user can set this header if they have some permission, right? If they have if they pass some subject access review, as a for example, that could totally be a thing also, right? And you know, there's a variety of ways to go about this. I don't want to speculate too much on that because, as far as I know, no one uses this for anything. But that, you know, this is Kubernetes, and everyone comes up with horrible things they want to do. So that was my thought there. That we continue, like, you know, we try to reach out to our community, see if anyone would be impacted by a change. And based on that feedback, it would tell us sort of the scope of the work for a KEP. Does that make sense?
Yeah. Just trying to understand a bit more like how the users can impact the audit ID. Like, is it just open to them and it is clear that they can modify it, or is it just because we don't have any verification and authentication, or at least authorization mechanism behind it?
Yeah, I don't think this is documented anywhere per se, but if you send a request to the Kubernetes API server and you set a header audit-ID, we will treat the value of that header as the audit ID instead of generating one ourselves. That's the gist. That's the behavior.
Okay.
As far as I know, this is not documented, written, or said as a thing that anyone should do. But we don't want to break anyone if it is valuable to them, right? Because at a bare minimum, any change would need to support aggregated API servers, right? Because aggregated API servers should be able to know that the real API server is telling them, here's the audit ID for this request. Keep flowing this through your stack, right? That way, because from the user's perspective, it is one request. It doesn't matter that's passing through 7 layers of proxying or whatever. So yeah, that's the general gist there.
Yeah, and I think your solution of reaching out to the ML is like the best approach that could be done.
Does anybody have any other thoughts? This was just something I thought of literally yesterday, so it might not be fully baked as an idea. Yeah. So,
sorry, one question. So, what would happen when we find, because the probability is quite high that someone on the world uses the audit ID? What would be the kind of the triage if it's not now a thing that we should not touch because it breaks too much of the infrastructure in the world, or where we say, okay, it's fine, we can deal with it? And if not so, would be there an option to maybe add a new header to the request, like trusted audit ID?
So, say this is widely dependent on, and it's really problematic to change, right? We could add a new flag to the API server that keeps the current behavior, but when set by the infrastructure admin to true or whatever, it changes to a more strict behavior, and that the fact that it's in that strict mode would be passed down to the KMS layer, so it knows if it can trust the audit ID. Because what we had wanted to do is basically we would go ahead and start with a nice UID and work on the KMS case and get that the ability to tie a KMS failure on the API server to KMS actual operations. We want to get that in, and in parallel we work on this audit ID work. And if we are successful in getting that into a better state, we can just go ahead and optimistically change the audit ID, the UID within that KMS call to be the audit ID, right? That way, in the future, without breaking any API thing, we just give you more information, right? So instead of it just being a randomly generated UID, it actually is the Kubernetes audit ID. So you, in those cases, you can actually tie it back to the Kubernetes audit event, right? But it doesn't, we're not saying that, any of these UIDs have any schema or necessarily any meaning today, right? We're just saying that you can use it for tracing, right? And if we get to a state where we can give you more, which is, yeah, if you happen to have Kubernetes audit events enabled and this particular request did generate an audit event, you can use the UID to tie them together. That would be nice. But that was sort of like the final end state that we had kind of hoped for, but we don't know, right? We don't know if we'll be able to make the audit ID get into a state where it can be trusted. And if we can, that's okay. We still want to have a UID in the KMS API for the ability to trace these things.
Would it be possible to kind of say, okay, no matter what, we just proceed with the flag? Because we would leave it up to the admins if they have some special weird setup where they think they can trust the client, and for the other people who are not trusting the clients could just proceed with the flag and then have an implementation for this no matter what, and really kind of push the decision back to the users.
Yeah, so like I find configuration to be mistakes. I find all configuration
to
be mistakes. It's basically like you have a configuration because you could not figure out how to do it right, so you push that to the user, to them, right? I don't like that. Now, this is minor, right? This is just a Boolean. It's not that big of a deal. I would like to push hard on the ability for Kubernetes to improve without end user interaction, right? Because what that would end up being is no one would be able to set this to true without possibly breaking their users or customers. So they'd almost likely keep it at false, and then maybe make some configuration in their infrastructure, right? Like, so I'm imagining GKE or AKS adding more knobs in their UI where you're like, no, I definitely do want my audit ID to be trusted. Like, this creates work for all of our ecosystem, and then users have to understand what it means, and those probably show up in this best practices security guide for Kubernetes. Make sure you check this box. Like, it funnels out in like a terrible kind of way, right?
And if you would do it the inverted way, that you need to set a flag in order to make clients be able to set the audit ID, then so if there are not many people or companies who are using this audit ID from the client's starting point, we could maybe say, okay, you need to add this flag to keep the previous functionality. So when clusters start to cause problems, they can investigate what's the issue and say, I need to add a flag to keep the previous logic.
Yeah, and that such an approach is fine. It's more with that approach, we would have to have a long stage rollout where the flag basically starts off not changing the behavior. Then with some amount of buffer, we say, cool, the behavior is about to change. You need to set it to whatever you want, and then it changes and so forth. That is a choice. And that one's not a bad approach. My personal desire would be to see if we can make it so that we just sort of force the ecosystem into like, no, you have to make this ID trustable. You cannot just arbitrarily allow it, right? And only if you get strong pushback in the other direction saying, no, like, here's my absurd use case for why I want to set this ID from actors that are completely untrusted and have no like attached authentication or something. Right.
If I can chime in and bring an ID to the discussion. So what we are trying to achieve is basically to have this trusted. And the example that you had with aggregated API and the API server means that if we want that site to be trusted, we'll need some kind of authorization to kind of say that changing the audit ID between an aggregated API and the API server is valid and should be done. It's something that is trusted. And if we introduce this kind of trusting chain, like this kind of authorization, why not make it even more generic and say that instead of having just that piece of code in the API server, have it really generic and allow users to authorize their own application to change the audit ID as per needed, like as if it was, for example, on their back rule, and they would allow the application to change this particular value as if it was basically an aggregated API that is talking to the API server. Like building this kind of trusted chain can be very generic to me. And we don't really need to tell the users that we will break them, because we will just add another layer of authorization that they will need to enable to be able to pursue.
Right. Whenever you have to enable something, you broke somebody, right? That is considered a breaking, right? So it can't be in that form without a giant rollout phase of some sort. So the one thing I'm trying to avoid here is too much change to aggregated API servers. So the front proxy mechanism that they use isn't really an authorization mechanism. It's an authentication mechanism, which is specifically that this actor is the front proxy and can set any user information on the incoming request, right? So because it can set any user information, it is by definition root, because it can just ask to be root if it wants to, right? It can always do that. So that path is kind of well defined already, but it's sort of outside of really both authentication and authorization, right? It's basically this actor is trusted, right? So that mechanism kind of exists and is fine. If we wanted to make it generic, it's a little bit harder because that tunnel isn't really authenticated, right? It's like fully trusted, and you know the thing doing that work is the front proxy. But from the Kubernetes API perspective, it's the original authenticated user that flows through that tunnel, through those headers. So it gets a little murky, right? Like you can't, like it's not that user you're authorizing, it's the fact that it was the front proxy that told you that you're authorizing. So it gets a little weird. I mean, we could totally make all of this work. But
you could authorize the proxy itself, but then
yeah, but it doesn't have an identity.
Yeah.
Right. It just
and even
is.
like if it was a client talking to the proxy in front of the API server, then there are multiple kind of proxy, and you can't really authorize one or the other, because like the request can go into any of them.
Yeah. But we don't necessarily need to get too far into this one particular thing. What I wanted to make sure is, so I had volunteered for the audit ID thing. I reached out to Tim, and then I can continue doing more audit ID stuff. But
So sorry, quick question. Remember, I think there was a concern about how, like during Bootstrap time, the API server wouldn't be generating audit ID because it's not being written to audit logs. So if in those cases, we can't use the audit ID at all.
Yes.
So we're back to UID then.
Yeah. So I think no matter what, the use of an audit ID, let's just pretend audit ID was always trusted. No matter what, it's an optimistic use. It has to be. So both for internal calls for the API server as it's filling its cache, those don't really have audit IDs associated with them, I think. But more specifically, even, there's no guarantee that an audit event is going to be generated for a particular request, right?
I guess I'm all for the improvement of who gets to generate audit ID. I just want to make sure it's a separate effort from like making KMS observability better, right? Because I feel like the scope is increasing quite a bit here, just because I think having the UID generated is already serving the purpose that we came here for. And also because the KMS improvement doc has a bunch of other capabilities that I think a lot of people really want to see, specifically around the performance aspect. So I'm questioning, are we using our time correctly here? If the UID serves a purpose that tell us, hey, you requested the encryption, decryption, hey, you actually did the encryption, decryption, I can correlate the request, I'm good. So then can we like, I'm wondering if our scope is increasing a bit beyond KMS at this point.
Yeah, that's totally fair. That's totally fair. So I guess the way I had framed it in my head, the like the cap that Anish is, working on writing and stuff, at this current stage does not need to say anything about audit ID. Like it just doesn't need to care about it. It's
Okay.
just say I'm going to do
Yep.
UID and that's what I'm doing.
Yep.
I was thinking of this as completely parallel, unrelated work that maybe we get to use in some meaningful way in the future.
I know. And selfishly, I want to see all the wonderful things in that doc get implemented. And given that we have limited time and resource, how do we effectively use that for the thing that most people want today?
Great. Yeah, I mean, I didn't know if there was, thinking through this, I don't know of other tracks of work related to KMS that can be done in parallel with the observability stuff and the reference implementation. If there are, then we should talk about those and prioritize them. I think you're just asking a priority question, right? Like what is priority? What should we do first?
I'm not saying we should drop anything. I'm just saying.
Yeah, no, totally.
Yeah. And also January 20th, right? We're on the 11th. So how do we get the CAP like actually opened and reviewed? And then, and the performance one, there's a lot of opinions there. So I want to make sure we have our time spent on the things that really make the biggest impact today.
I mean,
does that make sense? Yeah.
So I mean, within the next week, right? The most critical thing is the CAP. Right? Mm-hmm. Everything else can wait, and it's totally fine if it waits. Right? It's not really a big deal, right?
Yeah, and the UID it works, and it's not something that causes backward compatibility issues. So I guess I don't feel like we're gonna get a lot of pushbacks, right, to get that CAP merged.
Yeah, I mean, I the only real pushback I have on the UID is it's unclear. It's not even pushback. It's just unclear to me exactly how we guarantee that the UID gets logged, like always, to make sure that when there are failures, that it is guaranteed to be there in some way. That's it. That's literally my only question. I'm sure this is totally technically possible. We could totally make sure that this always occurs.
Okay.
But otherwise, I don't have any concerns from it. It seems totally fine. It seems to serve the purpose. It seems to be a very small iterative change. Seems totally fine.
Okay, so let's make sure that's addressed in the CAP. How do we make sure the UID is written to the audit log?
Oh, well, not the audit log, right? It would be in
the
API server log, right? Because we're
okay.
Because I think we're not going to try to put it as an audit annotation right now, right?
Mm-hmm.
Right. That's what we said. We were not going to worry about anything related to audit right now.
Right. Okay. So so log. Okay.
Yeah, so that's the thing we can focus on. So I don't know, like when an issue plan on trying to have the CAP open, certainly, we can just prioritize, whenever you have the CAP open, Rita, myself, and whoever else cares to review it can review it and get it in a state. And I think Wednesday is the SIG Auth meeting, right?
That was last week.
Was it last week? Sorry.
Yeah.
So we won't, I couldn't remember if Wednesday is SIG API machine, right? So we don't have another SIG Auth meeting before CAP freeze. The CAP freeze is before the next SIG Auth meeting.
Mm-hmm.
Right.
So I said once it's opened, let's just tag the SIG Auth for approval, right?
Yeah, totally.
Go ahead.
So the 20th you said, right? And the next SIG Auth meeting is on the 19th, right? So we have one day upfront, isn't it?
Okay, you might be right. Yes,
Okay,
you're right.
yeah.
Yeah, okay.
Sorry.
So that might be a little too close to matter. Like if it's not in by then, you might have missed the boat already. But sure, you are right. So what that tells me is I can go ahead and be like, I can go ahead and put this on there as like, we will talk about it, make sure we use the beginning of the meeting to look at any open questions and comments, get those addressed, and basically be like, all right, cool, this is implementable within 124, whatever we're saying. So I mean, that seems high priority. And then I suspect the work for this will not be that hard. I suspect it'll be pretty straightforward. Maybe we can talk about it maybe afterwards. I'm just trying to think of like, once we're done with this work, what are we going to do next? Are we going
I would love to talk about the performance part of the doc. And also we have a little bit of time left on this call, right? I also want to make sure, is there anything that we're adding in as part of this observability cap? How does that relate to the performance stuff, right? Anything that we need for performance that could be impacted by this? I don't think so. But I think originally we wanted to use the audit ID for other things, possibly. I could be wrong.
I think most of it is about debuggability at this point. Like for observability, for all the observability effort, like most of it seems to be focused on debuggability rather than actual performance.
Right.
I'm trying to see if I have the right doc. Is it the right doc there?
I can put the link here if it helps.
I think I have the right doc open. Right?
Yeah, that's the one. Yeah.
Right. So we haven't really talked about performance at all. So I mean, so we have what, 20 minutes, right? So we can just switch, right? We can just talk about performance stuff, and it's okay, you know, if we're not going to do any of it in 124. It'd be good to have the discussion started.
Yeah, also I think last time we talked about recovery, maybe we can also close on that one too. Like I think in this proposal, we said we could have an option where the user deletes it. And then we also talked about the cluster admin going and deleting the key in etcd. So maybe we can also close on that one to say what we intend to do. Do we want to leave it the way it is today, where list calls will fail and then the user knows and then they can go and delete it? Or
so it's been months now, but the last time we talked about this in SIG Auth, the feeling I got from folks on the call was that it is not the API server's responsibility to handle storage errors. Like it's just not in a position to do anything good about that, right? Just as you cannot work around your database being broken within your app, right? I mean, if etcd, like you can ignore all encryption at rest, just if you just are using etcd and you provisioned it with a really slow disk and it's completely overloaded and your list calls are failing because etcd can't keep up, the API server supposed to do anything about that? And I think the answer is, well, no, you're just supposed to go fix etcd. Is this different? I don't know. Like that, what I dislike about the KMS API and all the encryption APIs is they have put us in a place where we don't control the world for our storage, right? We rely on an external service that can arbitrarily fail for an operation that previously could effectively never fail, minus etcd being on fire, right? And so, and this same exact concern is the same concern I had brought up for the external service account signer KEP, that is basically like this, right? It will turn what is currently an API that can never fail, because the private key is directly provided to the API server and it uses it for signing. It will turn that API into one that can arbitrarily fail for unexpected network reasons, effectively, right? I don't know what the actual answer here is, like, because I'll stop talking and let y'all.
Well, yeah, one question from my side. was the issue that they like the thing that they were against the fact that we want to automate the deletion of the key that are corrupted, like of the data that cannot be decrypted anymore, or was it the addition of -- force delete to kubectl?
So think of it as one higher level up, which is when you're in this state, the Kubernetes API is unable to run its API guarantees. It cannot run finalizers. It cannot run those components, right? Those deletes and force deletes, all of those basically are just like additions that are like saying, hey, it's okay to violate the Kubernetes API. And it's like, but it's not. Like the Kubernetes API is authoritative here, right? And if you wish to violate those things, you basically need to use the backdoor of directly hitting the database and basically performing the violation, right? We should not give you a front door approach to bypassing finalizers because you have basically broken your cluster, right? Like,
Okay, yeah, makes sense.
and
I think it's
I don't.
kind of a good introduction to one idea that I had, which was to handle recovery via observability. Because via observability, we should be able to know whether any kind of data can be decrypted or not anymore, straight from the provider itself. So if we can bring back this information to the users to say that, hey, this secret or whatever cannot be decrypted because you don't have access to the key anymore or whatever, we just had an alert, then if we have enough information for them to then delete the key in etcd, that could be a workflow that works.
But you
So
would still be user initiated operation, right?
Yeah,
Like you tell me it's no longer encryptable or decryptable, I should say.
yeah. But the
Then
idea would be that instead of using kubectl to do that, they would use, for example, etcd kubectl to delete the object in the database, so that at least they have a way to recover.
So, but let's step back, right, and say that
Yeah.
this is an EKS cluster, an AKS cluster, or a GKE cluster, right, where you only have access to the Kubernetes API, right? Are we okay with basically saying in these environments where you're working with a provider that is managing the infrastructure for you and is handing you API server credentials? In that case, there's only two options. You make a support ticket with your provider and ask them to go press buttons, or every provider implements something, right? Some approach to handling this case, right? So you could imagine GKE has a button that says force delete, like do a full read of etcd, anything that fails, give me a list of it, and then I'll press a scary ass button that says nuke it, like nuke the things that are broken, right? That's not free, right? That's a lot of work, right? And at the end of the day, anyone writing that code is going to be scared as hell because they're giving you a button that is guaranteed to break something somewhere at some point in time, right? Like it is effectively like a support ticket. So is that okay? I don't know, right? And I think Rita,
I guess that's the issue whenever you try to automate deletion. Like whenever you try to automate any kind of deletion, you still have the same fears and the same concerns when doing so. That's why at first I only wanted to go through the alert pipeline, because via the alert, you could theoretically automate that, but most of the time you have an administrator doing something manual on the alert fire. They have to do a manual action, and this is like a bit safer but more tedious. But the idea would be that we still have a safe way to recover, even though it's tedious, but at least we have something. Because currently, like, we have nothing, and yeah, I'm not sure if we want to keep it that way.
So I think observability and just making it clear what is broken, I think is a great idea.
Yeah.
What I'm curious about, and I think Rita, this was something you had brought up a while back, is so yes, bad things will happen and we want to be able to recover from them. Is there a way within like the KMS API itself where we can make it very difficult for this to ever occur? So the particular case I'm thinking of is can we, I think the word you had used, Rita, was a lease. I'm naive to how KMS APIs work in the cloud KMSs. But today, when you're using the mechanism we have through the gRPC API is just basically encrypt and decrypt, right? If we consider an expansion of that interface, can we specifically hold a lease against the encryption keys that we are using and basically make it incredibly hard for you to get into this case, right? Like you have to like explicitly go out of your way to break something, right? Because today it's not within that contract, right? Like basically I feel like the KMS API should be like, hey, I'm using this, you can't have it right now, and if you insist, like you're basically agreeing to breaking the world, but like it should be very difficult.
Yeah,
right?
make it hard for any operations on KMS to actually impact the cluster.
Right. So, but again, I am naive to the cloud KMS APIs, and I don't know what that ends up looking, right? Like, because we have to, whatever we build as part of our gRPC API really has to.
Hey, this is part of the doc. Like we can write this as a, here's what you should be doing, right? If you're using this feature, you should turn on the lease lock feature in your KMS and maybe point them to the reference implementation to how to actually ensure that lease is there as part of the request or something.
Right, but what I'm saying is that part of like, how does that manifest within our gRPC API? And then how do we then manifest that within our storage layer to allow for like a high fidelity connection, right? So that way, without like a live cluster, you can still validate, right? Like if the cluster is completely turned off, but you have the etcd data, you should still be able to validate how that data was encrypted, right? What basically just that data set should tell you what leases you're currently holding, right?
So I think that is where we thought about passing the KEK back, right? Like so that it's actually stored in etcd, and then that metadata is available. So when the KMS plugin knows, oh, these are the KEKs that is currently used in etcd, so I cannot delete it, or no action should be taken on those, right? But also like we could land up in this particular problem in like one of three scenarios. One is the key is completely outside in KMS, gets deleted for some reason. Like if it's Azure Key Vault, let's say someone just deletes Azure Key Vault by mistake. So basically we are in a state where we cannot recover. Then the second one is also related to performance, right? Like we hit the rate limit because of some reason. So now we're not able to do the encrypt decrypt because all our calls are sequential today. And then we're in a state where like we're in a jail and then we can't break out of it soon enough. So like that is one scenario. And then the third one is rotation scenarios, right? Like the rotation, we do have good guidance today. Like we basically have steps in the KMS docs telling users that you basically run another provider with a different socket and then wait for all the existing secrets to be decrypted and re-encrypted. And then you go and remove the old provider. So we have guidance for those, but again, that can also lead into errors. So we can get into this error state in one of those three scenarios. So the lease probably covers one thing, but again, that is something we can tell users that like be really careful that you don't delete this key. And then for each particular KMS external store, we can tell them that like, hey, if this option's available, then this is how you enable and make sure it doesn't get accidentally deleted. But we still cannot prevent that in the cluster. Like if something does happen outside of the cluster, we still cannot prevent what happens in cluster. So we won't be able to recover.
Yeah, so yeah, I don't think we can ever get to a state, right? Just as you cannot prevent someone from deleting etcd. There's no way around it, right? Like they can destroy the data if they want to destroy the data. You did mention rotation. I'm curious if we have ideas and like the procedure you described is totally technically correct, but it's also relatively complex to orchestrate on like an HA environment, especially a KubeADM self-hosted or an OpenShift self-hosted. Like it is a lot of work. Like it's easier when you're not self-hosted, but it's not easy. It never gets easy. Is there, can we do something within the gRPC API for it to do rotation itself, right? Because if we are tracking within the Kubernetes API server what keys we're using, I could imagine a way of the gRPC API saying, hey, I would like a new key now on some interval, right? It gets a new key. It then initiates, it then initiates the rotation on its own based on, however it's going to, orchestrate within its net, right? And then you don't have to worry as much, right? So it's like basically this is hard code to write. It'd be cool if we wrote it ourselves once, tested it really well, and just told people don't write your own. We already did it right.
Yeah, I think that's a good idea, but the issue that I would see is that what we want with KMS, like the core idea behind this KMS feature is to have like the key handled somewhere else, like by a trusted entity, such as a KMS in a cloud provider, for example. And every operation related to this key, such as the generation and all that stuff, should be handled by the KMS. So for example, if any user said that they want their key to be rotated every 30 days in the KMS, I don't think the cluster itself should have its says to tell the KMS, hey, I want a new key now. No, it's not the policy that was defined in the KMS itself, so I don't think we should force rotation ourselves from the inside. And
Yeah,
my
so
idea behind, yeah, go ahead.
I was going to say, to be specific, what I'm more saying that we do is, so there's a set of configuration within the encryption configuration option. I want to keep it as is or smaller. I don't want to add any knobs there. What I would like is for the gRPC API to allow us to ask the plugin, how often do you want to do rotation, right? So in this case, it would be like, hey, tell me what your rotation policy is. And if it returns like 0, you're just saying no rotation. But if you return 30 days, that would help initiate that. But once that's there, then we can orchestrate it for you, right? That's what I want. Like, I want that difficulty of orchestration and the specifics of how the rotation needs to be done to be handled by us once correctly. But yeah, you're right. I don't think we need to be in the business of deciding how often that happens. Right? So
right. Just a proposition that I would have, because I was thinking about that also for our downstream use case. And basically, I think I mentioned in the first meeting, we discussed that a bit, and you told me that the KMS itself tells the API which key it has used to encrypt the data, like which one of the KEK. So if we keep in the API server, for example, a list of the last KEK, then we will know if a new one has been created by the KMS. And if that happened, we can initiate an actual rotation. So we don't really need like any kind of communication between the provider and KMS, because KMS should already be giving us enough information to figure out if a new key has been created or not.
So that is problematic today because we don't have any mechanism that looks across keys, right? So we only ever act on a single key. So if that action happened when all the API servers were not running and they came back up, they would be unaware of any change because they would start with the new key, right? And also it's problematic when you have many API servers because they all might not see that event, right? Only one of them would. So then how would the others know that it occurred? That kind of thing. Now, I'm not saying this is technically insurmountable. I just think we don't have a storage format that allows for that yet. But yeah, if we had a better storage format that tracked the key encryption key ID somewhere in there, and then also we built in a mechanism that basically was like an observability controller that's like, I'm going to look at everything that's being encrypted and be like, well, how is it being encrypted? And then it sees that, yeah, I've observed, like if there's a leader or whatever, I have observed that the key encryption ID being returned by the KMS is different than the one that was being previously used. I can automate a rotation now. Totally, that totally works.
Yeah, if I'm not wrong, this could be even simpler because if you create an object currently via the KMS, it will be encrypted, like the data key will be encrypted via the latest key encryption key. So at the very least, like if your first creation gives you a specific key ID, you will take that one as the latest key encryption key that exists. And then it's pretty easy to notice like some updates. You just have to compare like the key of the last encryption with the one that you had in your storage, like the one that you cached previously. And if the ID is different, then you can say, hey, a new key has been created. So you need to start like iterating over how to rotate all the data.
Hey, we have 2 minutes left. I thought it was kind of funny that we went from observability to recovery to rotation, but we didn't really talk about performance.
We're bad people. Sorry.
It's okay. This is all really helpful discussion nonetheless. But I do feel like we're probably at the point where I think if specific people have ideas, and it sounds like there are lots of really great ideas, it might be good to maybe start writing KEPs against these different topics, or like a within the existing doc, so that we can continuously iterate asynchronously, and then we can use this time to discuss what we are proposing. And then of course I personally, I also want to understand, like, of the few of us, other than the observability one, which one should we tackle next, right? Because there's a bunch of topics, as everybody mentioned: recovery, rotation, there's performance, and then there's also encryption config, hot load of encryption config, and then there's also different encryption protocols. It might be good to focus on one, so we don't go all over the place.
Yeah, totally.
So which one should we
Sure.
tackle next? Sorry, I'm trying to be like the person
The PM. You're being
a
our
little
PM.
bit.
You're like, stop engineering.
No, I mean, these are really great though. And we are documenting the discussion as it goes. So, but I am wondering, which one do we think will make the most impact, right?
But the most impact is definitely performance. Like recovery is only a few people, but we are,
I think so too.
I mean, we are close to kind of having an idea of how to do the recovery, or at least we have a lot of ideas or things that we could document or do. So this is close to conclusion, whereas like performance still needs to be discussed completely. So, but
so
performance
can
is
I?
way more important.
Yeah. Does everybody share that sentiment? Yeah.
I think the most likely failure mode in production today would be performance, right? Like,
yes, I agree.
Recovery only happens when bad things really go wrong, and you probably did it yourself, like you caused self-harm.
I mean, I'll be honest, I started working on this because of performance.
No,
all the other stuff are important, but without that, we can't even tell people to really use it. So
yeah, if you really use Kubernetes and have a lot of secrets,
yeah,
performance issue, or a lot of things you encrypt, right? Like, I feel like we say that you should encrypt secrets. I find that annoying. I feel like you should say encrypt everything, because just assume it's a secret.
I know.
But,
okay, so given that, should we, the call to action is everybody on this call look at the performance stuff, right? Ideas, questions within the doc, and then let's just work on it asyncly. And then next Monday, it's not Monday, next Tuesday, let's discuss this, focus on performance. Yeah.
Well, to be fair, first thing is review initials kept.
Yeah, absolutely. I assume that everybody's going to do that anyway, right? So
that's first thing, and then we'll work on performance. All right, cool.
Awesome. Thank you, Anish.
Before we wrap it up, you mentioned, like, for observability, you mentioned reference library. Is it the discussion that we had in the first meeting about like adding metrics as a library, or is it something different?
I think long term we want a reference implementation that has every one of these topics in there. But initially, right? But initially, as you said, once we get the KEP approved for observability, we can always start there first. So whatever gets approved, we can add them incrementally.
Okay. Yeah, makes sense.
I think for observability, we were considering both like Prometheus style metrics and open tracing style metrics or traces, whatever the correct term is. Like,
Okay. Yeah, that would make sense. Definitely.
Open telemetry. Yeah.
Christoph, did you have something?
Yes, so what are the exact action items? Because we need to be more or less done by next Tuesday, right? So that we can kind of finish everything up.
First
So-
thing is, once
Mhm.
Anish pushes the PR for KEP, let's all go review and then ping SIG Auth approvers. And then we will also present it at the next Wednesday's SIG Auth call, just to close any open items. And then in the meantime, if you have time, think about all the questions and edge cases that we want to discuss asynchronously or synchronously on this call for performance.
Okay, cool. So I will watch for anything from Anish on GitHub and then jump on it.
Mhm.
All right, I gotta drop y'all. Thanks.
All
everyone.
right, thank you,
Thank you.
everybody. Bye.
Thank you.
Bye.
Bye.